We discussed presently one single core, well basically single unit, but it turns out modern processors have many cores. Okay. In your own laptop you would have quad core, nowadays is octa core, 8 cores are coming, and the best machines right now have 128 cores available now. So, let us look at some real HPC processors. Okay. I can't cover many of them, but I will cover only 2 of them. One of them is not HPC, but is a very interesting design. So, I will give you some, I will have some discussion on that. Okay, so, this is called multi-core processors. So, multi-core means right now we had single core which had adders and instruction registers and all that. Okay. But now we can have in the chip there will be different units of what I showed. Each of them have their own registers, okay, and they can do their operation independently. Okay, so, that speeds up. I mean, if you can write a good code, single processor with 64 cores can speed up your code by 60 times. Okay. So, instead of buying 60 processors of single core, it is good idea to have 64 cores sitting inside a single chip. Okay. So, presently these are the 2 top processors. AMD is a company. So, this is the release this year only, Bergamo, EPIC. So, they are different series. So, these are HPC processors which is very expensive. This could cost you around, I do not know, this one is around probably 4 lakhs of rupees, okay, and this is probably 10 lakh. So, these are expensive CPUs, and you do not fit this inside a laptop. So, it is going to be heat up the laptop. So, it is not for that. Of course, the laptop cost will also go up. So, it is not for laptop, this is for HPC. Okay. So, let us see what is there inside ROM. So, I will show you what is there inside ROM. This has 128 cores and this is 64 cores, and it turns out there is some design has not changed much from ROM to core. This is old processor, is around 6 years old processors, but this one is fresh. Okay. So, what you learned from ROM is similar for Bergamo. Okay, so, this is how the ROM processor looks like. So, there are blocks, okay. This is called CCX, okay. I think core something I forgot the full form. So, there are how many of them? 16 of them, and each of this block has 4 cores each, and it has its own cache. Okay. So, this each block, by the way, having close by cores is also advantageous for one very important reason, that the data communication will be fast. So, if I had one core, one CPU and another CPU, I had to talk, and that will be slow, but if the cores are close by, then it is fast. Actually, in fact, speed depends on one thing is distance by speed of communication. So, we are close and we can communicate faster. Okay. So, that is a simple logic. So, these are 4 cores and 16 of them, and this is one, well, it is an expanded view of that CCX, this block. So, core 0, core 1, core 2, core 3, and this L1 cache which I discussed. No, there was a cache which L1 is the fastest cache. L1 is just sitting close to the core. Okay. L2 cache is also close by, and each processor or each core, sorry, not each core, okay, each core has its own L1 and L2 cache. Okay. So, it does not have to look elsewhere. So, if you have vector operation, then each of them is packed with lot of data, and they can do it very fast. Okay. From cache to register movement is quite fast. I am going to show you in few, well, probably today only, how things move. What time, how much time does it take to move from L1 to register. So, this is L1, L2, and now L3 cache is shared among the 4 cores. Okay. So, this is what is the data available close to the cores. Now, it is quite possible that this set of cores want to talk to this set of cores, right. We have big operations like for example, matrix inversion, a lot of data is required from one part to other part. So, this is communicated across this block. This is a big block sitting in center which has wires, basically these have wires inside, and these guys will, this cores will talk across to other cores via the wires inside. Okay. Also, I need to fetch data from RAM. So, RAM data will come via memory controller, okay, this memory controller, and you can also talk to other peripherals, for example, printer. So, this is called PCI lanes and they will talk to PCI. The thing is, we have this huge number of cores available within a processor, and the cache is also close to the processor. Okay. So, this is one way to speed up our computation, and this has well, we can look at some numbers now. How much operations can it do? Okay. So, this is some detail about these two processes. Okay, let us look at some numbers. Okay. So, it is called 7 nanometer technology for ROM, and Bergamo is 5 nanometer technology, 32 billion and 70 billion transistors. Numbers of CPU, as I said, is 64 and 128. We will discuss about threads bit later. It is a very important concept, but I think we will delay it for future discussion. Clock speed is not much. Okay. It is not going for 5 gigahertz, is keeping it around 2.3, 2. Okay. It can be boosted up to higher clock speed. The L1 cache is 32 for each core kilobytes. So, and multiply by 64 because there are 64 cores. So, 4 megabytes of cache, L1 cache, which is big. So, something like 10 power 6. So, 1 million data will require 8 megabytes, right. So, I can put half a million of data inside the L1 cache. It is a big number. Okay. 2D array of 1000 square is approximately fitting inside a L1 cache. L2 cache is even bigger, 32 MB, and L3 cache is 256 MB. So, there is a pretty big cache with ROM processor. Now, this is, we will discuss this bit later. So, PCI is a communicator from RAM to other peripherals, or we will see that in a motherboard there are 2 ROM processors, then one ROM processor needs to talk to another ROM processor. You understand? This ROM processor, this ROM processor, there are 64 cores here and 64 cores here, but they need to talk. So, there are machines with 2 or there are machines with 4 ROM. So, we have this machine, 2 of them sitting inside, but we can put 4 of them as well. Okay. And they need to talk, and they will talk via PCI Express. System memory, we will come to that bit later, is the DDR4 and the DDR5. Memory channels is 8. So, I should mention this. So, this is CPU, but there are memories in these two sides, memory slots. We see the picture, but then how many wires are going to the memory? If a single wire, then it is going to be slow, right. So, we have only one highway to Lucknow, and that is slow, right. But you have more highways and more data can flow. So, these are highways for data flow, and so memory channels for ROM is 8 and Bergamo is 12, and this has made a difference. So, earlier there used to be 4, Intel had 6, but now they increased the memory channels to 8, and 225 watt of power, and this 320 watts of power requirement. Okay, now, how many operations can it do per second? Okay, it is a good number to estimate. Now, there is a site called top500.org. You should look at this site, and this site has the fastest 500 supercomputers of the world. Okay. And you will see that many of them have ROM processor, but presently the GPUs are more prominent. So, many of the supercomputers are using GPU and they are getting speed up via GPU, but ROM also is an important processor. Okay. But anyway, so let us look at ROM processor speed, and you need something similar for GPU, but we will do it later. So, ROM processor, how will I estimate speed? So, it is very simple. So, each core there is a clock, no. So, clock is around 2.2 gigahertz, and each core can do 16 operations per clock cycle. I told you vectorization can do 16. So, then you multiply by the number of cores, clock speed, and how many operations per clock cycle, and that will give you number of operations it can possibly do. It does not happen, we never get the peak efficiency, but that is this is called peak efficiency. Okay. So, that is how we compute. So, each core can do 16 double precision operations per core per cycle. So, flops is floating, FL, you know, floating. Floating is kind of real, I will not get into details why it is called floating. Op is operation, okay, and S for second. So, how many operations per second? Flops. Okay. So, maximum flop is 64 cores, within that 16 operations per clock cycle, and per second how many clocks ticks we can get, 2.5 gigahertz. So, if you multiply everything is around 2.5 teraflops. Okay. That means 2.5 times 10 power 12 operations it can do. Is that clear? I mean, you can multiply 16 times 64 is around 1000. Okay. So, it is easy to see. This is a peak performance, but now there are people who write codes to test how much efficiency I am going to get. Okay. So, there are tests you can look at in web pages, in fact, the matrix operation, okay. And these tests give you 2 teraflops, not 2.5, but 2. So, it is possible to get close to the peak performance, but you have to write very good codes, okay, to reach there. And the Bergamo peak speed we can, well, the number of cores has doubled. Okay. So, that immediately give you 2.5 times 2, right, that is not some big guess you can, I mean, you do not need a huge brain wave to estimate that it should be 2.5 times 2. Okay. But this is number given in website, I took from there. So, it is around 5.3 teraflops. Okay. So, this is a big performance. So, our CPU, our CC has a machine which is 1 petaflop. Okay. So, 1 petaflop is 10 power 15. Okay. So, how many of these do you need? Peak. So, each of them is 2.5, well, let us say 5. So, you got Bergamo. So, 5 into 200, no? They will give you 1000 times. So, 200 Bergamo can give you in principle 1 petaflop. Okay. But there is a loss. So, Bergamos are here, they sit inside. So, I am going to show you how these are assembled. There is a communication loss when you go from one Bergamo to the next Bergamo, and that speeds up, that slows down a lot. So, typically even if I have the full machine, a petaflop machine, I will get 1% efficiency, that is a typical number. So, it is 10 power 15 operations per second, but I can get 10 power 13, that is a good code if you can get 1%. Okay. So, I mean, you can do it yourself on, well, you can't get this big machine for yourself, but you can run on your laptop, you can estimate the peak performance and see how much you get out of that. Okay. Now, let us look at some more hardware. Well, this is a comparison I took from another website, in fact YouTube, I took a snapshot. So, Bergamo is which one is that? This one, the number I forget. Okay. So, this is the top speed unit. So, this is called spec, this is the rating. Okay. Spec is specification rate 2017, FP is floating point base results. Okay. So, the unit, I do not know the exact unit what this 2000 means, but this one is giving around 2000, and 7742 which is EPIC ROM, which is around this 500, So, Bergamo is close to 2000, okay, and 7742 is around 750 in this for this program. So, you do not expect this ratio 2.5 to 5 to work for all the codes. So, this set of programs, in fact not one program, they use quite a few programs, an average. So, this is 750, right, I mean this is 750, you can see it is basically less than 2 times as fast as Bergamo. So, these are important numbers when you trying to buy a machine, big machine, and we need to weigh, I mean cost versus how much space, also cooling. I mean if you have big machine, then you need big cooling. So, if you can pack more power in a small set of processors, then it is better. Okay, now, let us look at Intel processor, which is not as good, but some spec ratings are giving Intel very good performance. So, it is not number of, if you increase number of cores, you do not expect things to be proportionally fast, but I do not have the comparison really between the two, and I do not want to tell in public, because it is not good actually to compare two processors of two different companies. So, it has 32 cores, slightly older technology, and cache is this L3 cache. L1, L2 cache I could not find, its L3 cache is 48 MB, which is good, power is of same order, and I do not exactly know the flop rating of this. You can compute by multiplying 32 by this clock speed, and you can assume 16 operations per second. So, that will come out to be roughly half of ROM, but I do not know, I do not have the exact detail of ROM processor. I would, to estimate, I will just do that number of cores, clock speed multiplied by 16, it can also do 16 operations per second. Okay. But there are some more things inside, number of channels and how quickly it can talk and so on. Okay. So, how do we connect processors with the memory? When we look at memory, then we will find that memory is, so this is CPU, let us think of single CPU, but memory is not sitting on single slot, single memory slot. There are a lot of memory DIMMs called, these are called DIMM. So, your laptop may not have all memory sitting in single DIMM, but it could be 2 of them. Okay. I will show a picture when I discuss memory. So, there are several DIMMs. Now, there are cores inside CPU, right. Now, this core wants to talk to this memory. Of course, it also wants to talk to this memory bit later, fine. So, how do I manage it? So, the standard hardware I am going to show you is this. So, these are, you can think of cores, or in fact, it is possible that we can have processors, 2 processors, CPU 1, CPU 2, and they are talking to DIMMs. So, various stuff. So, you can either think of them as cores or as a processor. So, P0 wants to talk to M1, this is called crossbar switch. So, these are switch, okay, they have switch inside. So, P0 wants to talk, so then P0 will come. Well, P2 is, so they send their address as well, okay. So, who do I want to talk to? So, P0 he says, well, I want to talk to M1. So, it has to go via this path road, and P1 say, well, P0 wants to talk to M1, let go. So, the traffic, this car is passing by this, it does not do anything, it just lets go, and talk goes to M1, and then M1 gives the data and it flows back. Okay. So, this is switch. So, it has some address, and the address is seen by the switch. Switch is intelligent, switch has hardware which will detect the address and then let go. Okay. So, this is called crossbar switch, and that is how this communication is managed. For us, well, it is good to know, but not quite critical. This is a motherboard. So, this is a single processor. This is called Supermicro, is one of the companies which make motherboards, and these are 2 processors, and these are RAM slots. So, how many RAM slots are there? 8 of them, 4 here and 4 here. So, that is what the talking of core inside this processor to the RAM, and is done via crossbar, which will be hidden inside this motherboard. Okay. And here of course, this processor wants to talk to that, and it has more data. So, this is more expensive, this motherboard is more expensive. Okay, so, let us quickly discuss one more processor, Apple processor. This is not this for desktops, or in fact, mostly laptop desktop both. So, as I told you before, this chip has CPU, GPU, RAM all inside. Okay, it is a clever design. Remember in the motherboard I showed you that RAM was outside, but you put RAM inside, it has a advantage because it is close by, and also the same RAM can be accessed by GPU and CPU. Okay. So, this is called uniform memory, okay, which will, I think I will cover a bit of it later. So, it is called UMA architecture, okay, uniform memory architecture, and is faster and also energy efficient. So, let us look at some numbers. So, you see cache is here, CPU, GPU, even neural engine for AI applications is also inside, this RAM. Okay. So, and this is a connection, okay, you can see there are connections via this block. So, let us look at some numbers. So, we can, well, the RAM is not very big and number of cores is also not very big, but it has lot of transistors. Huh? So, CPU, GPU, everything inside, there are 134 billion transistors. Whether Apple is one of the most innovative company, so you should look at history of Apple. That company has huge innovations. I mean, it is one of the real innovative company among the giants. Like Intel is no small company, but Apple excels in innovation. So, this is some inside picture, but we ignore it now. So, presently the most recent chip is called M2 Ultra chip. Let us go through M2 Ultra chip. M1 was slightly old chip. So, it is 5 nanometer technology, which is like ROM technology. Okay. So, laptop CPU is very good CPU. It has 134 billion transistors, 16 high performance cores, but 16 is a good number. So, this laptop is very good. So, some of these things are as good as servers. Okay. Energy efficient core is 8. So, this for browsing, email, which is not very fast, but it is also energy efficient. So, for you are checking mail, you do not want to use a fast processor, no, it will be less energy consuming. So, together you have 24 and clock speed is slightly higher, 3.49. GPU core is not as good as NVIDIA's GPUs, but it is good number for graphics. For laptop graphics is great. Okay. And the L1 cache is also not very bad. So, total I can multiply 192 plus 1, well, is I forgot to put the number, but is significant cache, and they are all sitting inside a chip. Okay. Of course, ROM also has L1 cache inside, it better be. So, these are all close by, and 64 MB of L2 cache and 8 MB for energy efficient. They have segregated the cache. In laptop I can do several things, I am running a program for video editing, and I may also be doing web browsing. So, they can go on simultaneously. This is L3 cache, last level cache is L3 cache, okay, which is quite large, 96 MB. So, unified memory I can put 32 GB, but it is expensive, we normally put 8 GB or 16 GB. And power, you can just look at the power, is 24 to 36 watt of power. Computer ROM, which required 225 watts of power. So, it is 1/10, and that is the reason this laptop battery lasts for literally 18 hours or so. Okay. 2 days you do not need to charge. So, these are innovations, and some of you should get into it if you are interested. Okay. For HPC application, threading makes program the performance worse. Threading is not great is so far. So, I mean threading, you can have 2 threads, but they should do different things. If it is the same thing, then they share resources, and the overall time becomes bigger, larger.